Have you ever seen one of those incredible AI-generated images and just wondered, how? It really does feel like modern-day magic, turning what looks like TV static into a work of art. Well, let's pull back the curtain and see exactly how it works.
It's one of the most mind-bending ideas in technology today. We're not talking about just tweaking a photo or slapping on a filter. We're talking about starting with a canvas of complete, utter, chaotic randomness and ending up with something breathtaking, coherent, and often really beautiful.
So that's the big question, right? How on earth is that possible? Well, that is the central mystery we are going to unravel in this explainer. It's a journey that takes us through some controlled destruction, what seems like an impossible problem, and thankfully, a very, very clever shortcut.
Okay, so to figure out how to build an image out of noise, we first have to do something that sounds kind of backward. We need to understand how to perfectly and methodically destroy an image with noise. This whole thing is called the forward process. The process, believe it or not, is actually super simple. You start with any clear image. We'll call it X0. Then, in each step, you add just a tiny, very precise amount of something called Gaussian noise. Just think of it as pure staticky randomness. Then you do it again and again, repeating this process about 1,000 times until the original image is completely gone, totally lost in a sea of static.
Now, the key thing to get here is that this is a totally known process. It's a one-way street, and we have the exact map. There's no AI, no learning, no guesswork involved. It's just a predictable mathematical formula for taking an image apart.
Simple enough, right? But that brings us to the real challenge. If adding noise is so easy, why can't we just do it in reverse? Well, this is where science hit a massive mathematical wall for a long time.
And this really lays out the problem perfectly. Going forward is easy. It's like scrambling an egg. But going backward? That's like trying to unscramble the egg. It seems impossible. There's just no simple formula to perfectly subtract the noise and get back to where you started. The path is lost.
So for years, this problem just seemed unsolvable, a dead end. But the breakthrough wasn't some ridiculously complex equation. It was about reframing the problem entirely with a wonderfully elegant shortcut.
The big insight was to just stop. Stop trying to make that one giant, impossible leap all the way from total chaos back to a perfect picture. The real solution is way more subtle. Instead of looking for one big answer, the solution was to get a tiny piece of the answer, but to get it 1,000 times. And the hero of our story is a highly specialized neural network.
And this is the secret sauce. The AI, our noise predictor, was trained to do just one thing, and one thing only. It looks at a noisy image and simply predicts the last little bit of noise that was added. It's not trying to see the final image. It's not trying to imagine a cat or a mountain. Its only job is to spot the last puff of static.
So you might be wondering, how does this little one-trick pony of a neural network create a masterpiece? Well, it does its simple job, but it does it over and over and over again in this incredibly powerful loop. Okay, so here's how it all comes together. We start with a canvas of pure static, total chaos. Then the noise predictor looks at it and says, okay, I think this is the noise pattern here. Then we just subtract that predicted noise, and suddenly a faint hint of structure appears. A ghost of an image. Then we do it again. Predict the noise, subtract it. Predict, subtract. Over and over, hundreds of times. It's just like a sculptor chipping away at a block of stone. And with every tiny chip, the art underneath becomes a little bit clearer. And that's the real beauty of this whole thing. It's not one giant, impossible leap from chaos to order. The genius of it is transforming one huge problem into 1,000 small, totally solvable ones.
All right, so let's quickly recap the big ideas. First, the forward process systematically destroys an image with noise. Simple. Second, trying to reverse that directly is basically impossible. The solution? A clever neural network that just predicts the noise at each little step. And finally, by repeating that simple prediction and subtraction 1,000 times, a brand new image is literally created from nothing.
This whole thing leaves us with a pretty fascinating thought. This process is all about finding a coherent signal that's hidden inside of chaos. Today, it's finding beautiful images. But what about tomorrow? What other valuable hidden patterns in finance, in medicine, in the vast noise of data all around us are just waiting for the right algorithm to find them?